Hello everyone and welcome to this video on how to use the LAVAAN software easily for structural equation modeling and confirmatory factor analysis. My name is Geiser, I'm an instructor with QuantFish, and on this channel I present weekly statistics tutorials, usually related to multivariate statistical methods including factor analysis, structural equation modeling, multi-level modeling, and latent class analysis. If this is something that interests you, then please subscribe to this channel. Also, don't forget to check out the description for additional resources, including workshops that I teach for QuantFish. In this video, I want to show you an easy way to run factor analysis and structural equation modeling using the LAVAAN package in R without actually having to deal with R syntax or the R program. And so this is something that is really useful when you're a beginner with structural equation modeling, with factor analysis, with LAVAAN. You can use the free software program JASP, which has a user-friendly interface that allows you to do many things with point and click. And so that way, you can use the benefits of a free software like LAVAAN of R without actually having to do a lot of the coding. A lot of that is done for you, and then you can learn from that. You can save the syntax, and you can then slowly learn how to do the coding in a software like LAVAAN. So let's get started here, and I want to show you the options that this JASP software has to use LAVAAN through a point-and-click interface for factor analysis and structural equation modeling. And it's actually surprising what all you can do with just a few mouse clicks in this program. JASP, like LAVAAN and R, is completely free. You can download it from the internet, and it's very, very intuitive. So a lot of things are self-explanatory. They have a point-and-click menu where basically everything is in your face without being overwhelming. You can see all the different tests and all the different statistical procedures. You click on them, and a lot of it is very, very intuitive in terms of where do I find what, as we will see. What is also really easy with JASP is to open data. So you don't have to think about converting, for example, your SPSS data file or some other data file into a specific format for whatever structural equation modeling program you're using. You can just simply open an SPSS data file or other database. And so here I'm going to go to open, and I already have an SPSS file that I recently worked with that's called math.sav. So I'm going to open that, and it readily imports my SPSS data file. Once you have a data file open, you can see that all these statistical analyses here are being activated. So now you can click on any of these and select what you want. You can run simple statistics like descriptives. You can run inferential statistics here like t-test and ANOVA. There's a regression option, and you can see there's a factor option, and also there's an SEM option right here. So I want to walk you through these so you can see what the options are and how easy the program makes it for you to specify a lot of different models. And I will also point out some of the limitations here. So let's do the factor option first. You can see that it has three different options: principal component analysis, exploratory factor analysis, and confirmatory factor analysis. And so the exploratory factor analysis option is actually quite nice because it allows you to use either continuous data or categorical, meaning ordinal data, and it uses the correct correlation or covariance matrices for analysis with either continuous or categorical and ordinal variables. It has a lot of options for selecting the number of factors, including parallel analysis that is automated. In that exploratory factor analysis routine, it has different estimation methods, including maximum likelihood factor analysis or principal axis factoring. So a lot of different options. If you're more interested in that, I have a separate video where I talk about exploratory factor analysis in JASP in more detail. So check out that video. Here I want to focus more on confirmatory factor analysis models and structural equation models. So the confirmatory factor analysis option is also very nice, and let's go click on that to find out a little bit more. So it's very, very intuitive, and it allows you to specify all kinds of different confirmatory factor analysis models. You can define your factors here. So for example, I could define my first factor that I can also label the way I want. For example, this could be a spatial factor for measuring spatial abilities, and then I can use 2 indicators here from a mental rotations test that could be indicators of a spatial factor. You can see that already on the right hand side, JASP is trying to do something, and here it says the model could not be estimated, and that's because with only 2 indicators and a single factor that is not correlated with another variable in the model, this model is under-identified unless we set the loadings equal. So right now this model cannot be estimated, but once we add a second factor, which we can simply do by clicking on this plus symbol here, then the model will be identified. So we could do a second factor math, where we have 4 different subscales of a math test as indicators of that factor, and voila, you can see on the right hand side now this model can be estimated. There's a chi-square value for the model here given, model fit, and you can see, wow, it fits well, so it's not rejected. The p-value is 0.134, so wonderful analysis with 2 factors here, and you can see parameter estimates are given here, unstandardized factor loadings are given by default, standard errors, z-statistics, p-values, confidence intervals, the factor variances are given, and the factor covariance, which here is equal to a correlation between, because the factors are standardized by default, so we have a variance of 1 for both factors, and then as a result the covariance is equal to the correlation. So you can see that the factors are correlated 0.335, and there's also a test statistic for that correlation. So you get all the different information that you would get in a standard program for structural equation modeling, and it's by point and click. It's super easy. LAVAAN is used behind the scenes. The syntax can be saved, as we will see if you want to look at the syntax, and you could specify all kinds of different factor models. You could turn this into a second order factor model here by selecting factors that measure a second order factor, and you have a lot of different model options. You could include a mean structure, you could have uncorrelated factors, you could choose a different way to identify the model. Instead of fixing factor variances to 1, you could use a marker variable approach where 1 factor loading per factor is fixed to 1. You could use effects coding, so that's all here automated. You could also add residual covariances for indicators that share residual associations above and beyond what they share with the factors. You could run the model as a multi-group CFA by choosing a grouping variable and then testing different forms of measurement invariance or measurement equivalence here under this option invariance testing. You can request additional outputs such as additional fit statistics, R squared, composite reliability such as omega, the McDonald omega composite reliability and Cronbach's alpha can be requested, and you can save the syntax, which is great. So you can learn LAVAAN without having to write LAVAAN code. So you can click on show LAVAAN syntax, and then at the very bottom you get the model syntax for this model that you could use in R in the LAVAAN package to run a factor model. You can also generate a path diagram under plots. So when you go to model plot, you get a path diagram created by JASP where you can look at your model. It takes a little bit of time here for it to create that path diagram that will then be added to your output file. You can also choose what to display in the graph, for example, parameter estimates or standardized parameter estimates by clicking on this little icon here, and you can see then the parameters are imported. In this case, those are the unstandardized loadings. You can also select the standardized loadings, and then you get those standardized loadings here in the correlation, as well as the standardized residual variances in your path diagram. So that's also nice. And then on advanced, we have a whole bunch more options. We can choose what kinds of standard errors we would like, either the standard asymptotic standard errors or robust or bootstrap standard errors. We can choose a different type of estimator for estimating model parameters and fit statistics. We can choose to display the standardized solution by clicking on standardization all. And then the standardized parameter estimates will be added to our tables above. So you can see the last column now is new, standardized estimates all. Those would be the standardized residual variances in this table. Here we have the standardized factor covariance, which obviously is identical to this one here because the factors are already standardized or were already standardized. So we have, again, the correlation point 335. And we have the standardized loadings in the factor loadings table. And those tables are really nice already. They look pretty much like they are in APA style. You can copy them. You can click on this arrow and then on copy. You can paste it into a Word document or a PowerPoint file. So it's very, very convenient and you don't have to write the syntax. Now that's it for confirmatory factor analysis. So that's very, very easy to do. Now let's take a look at what else is offered under the SEM option here in JASP. And so when we click on this, we can see that there is a button structural equation modeling at the top. There's also partial least squares SEM, which I'm not going to cover here. There's mediation analysis that you can do. There's a mimic model option and there's a latent growth model option. Now, a latent growth model is also really easy to specify in JASP. So let's do that first. Let's click on latent growth. And then you can see on the left-hand side, our confirmatory factor analysis is still there, but now latent growth is the current type of analysis that we're doing. If you want to go back to your CFA and change something, you can always go back. And so you can change your model or add stuff. And so that is still there. And then below that now is our latent growth model. And so here you can see we can just simply specify a growth model by selecting indicators. So this was the wrong field. So I need to go in here. So let's put them back to our list and then put them into the first field variable. So those would be the indicators of the growth curve factor. You can see it's already being estimated here and you can see it's not fitting well. So a linear growth curve model is the default and that does not fit these four variables. Here the chi-square is over 300, 5 degrees of freedom, and the p-value is smaller than 0.001. So that model is rejected. I just want to show you how it works. This doesn't really make sense here because this is not even longitudinal data. But just to show you how it works, you put your growth curve indicators in the variables field. You could have predictors of the growth curve that you would put in here under regressions. You can see that the regressions then are added of the intercept and slope factor on the predictor MRT sum. So those are then given. So it's very easy to specify a latent growth curve model with or without covariates. So that can here also be added to the growth curve model easily. Under model options, you could turn this into a quadratic growth curve model or a cubic growth curve model. Again, you can request additional output, including fit measures, R-squared, standardized estimates, and others. You can again show the LAVAAN syntax. So this analysis again is based on the LAVAAN program. And so if you want to learn LAVAAN, then it will generate the syntax for you, which is very nice. Next, let's take a look at a mimic model. So a mimic model is one where you have a latent factor that is predicted by something. And so this option is limited to a single factor. So for example, we could have again our math factor specified right here. So this would be a factor model so far with no predictors. And you can see that not much is happening here on the right hand side yet because JASP is waiting for us to define predictor variables of that math factor. So I could, for example, use this variable MRT sum as a predictor. And so then I have a single factor model that is predicted by this manifest variable. Now this option is limited to predicting a single latent factor by one manifest variable or multiple manifest predictor variables. So here we have a model where MRT sum as a manifest predictor variable predicts this factor with 4 indicators, our math factor. And so that's a pretty limited mimic model. that you can use here, but you can specify a more or a larger mimic model with more latent factors, where the latent factors predict one another, by choosing the structural equation modeling option at the very top here. So that allows you to specify multiple latent variables that have a structural model with structural regressions. And so let's see how that works. When we click on that, we can see that in the structural equation modeling option, we actually do not have a point and click option for the factors and factor regressions, unfortunately. So this is maybe something that they will add in the future. But what you have to do here is you have to use an existing LAVAAN syntax, or you have to write the LAVAAN syntax yourself. In this case, I've already prepared a LAVAAN syntax that I'm pasting here into the model field. And so you can see in my syntax, the cognitive factor is defined by 3 indicators: KFT verbal, KFT quantitative, and KFT figural. And there are loadings that are labeled lambda 1, lambda 2, and lambda 3. And then I have a second factor, math, with the 4 math subscales: math 1, math 2, math 3, math 4, and loadings lambda 4, lambda 5, lambda 6, lambda 7. And then I have my structural regression. Math is regressed on cognitive. So the cognitive factor here is the predictor, the math factor is the outcome or dependent variable, and beta 1 is my structural or latent regression coefficient for the regression of the math factor on the cognitive factor. And so then I can just simply hit Control Enter to apply the syntax, and then it will be run. You can see that then we get the model fit statistics on the right hand side. So you can see there's a chi-square again given for the model. The model is not rejected with a p-value of 0.075. So this model also fits the data well. I get information criteria, which here would only be meaningful if I use them in relation to another model to see if this model is better or worse than an alternative model. I get parameter estimates, specifically here the unstandardized factor loadings, and then I get my latent regression coefficient beta 1 here, with the estimate being statistically significant. This is the unstandardized beta in this case. So this is a linear regression coefficient, and it's statistically significant, indicating that the cognitive factor is a significant predictor of the math factor. And so this is then an option where you can specify a full structural equation model, but you have to know the LAVAAN syntax. Other than that, though, it's nice because you don't have to know all the LAVAAN syntax for all the other options. So for example, if you want additional output, such as additional fit measures, R-squared, observed covariances, model implied covariances, residual covariances, standardized residuals, standardized parameter estimates, a path diagram, modification indices, all that is being generated for you without you having to write the LAVAAN syntax for that SEM. So all you need to know is how to specify a model in LAVAAN, and then once you know that, you can put your syntax for the model here, and all the other options are point and click, or at least many of the options that LAVAAN has. So you can see all those different fit indices are then generated, and R-squared is generated. We now get the standardized solution here at the end of our tables for both the loadings and the regression coefficients, and also the variances. We get our observed covariance matrix, model implied covariance matrix, residual covariance matrix, all these kinds of things you can request then without having to write more syntax. Also, there are more options here under model, where you could include a mean structure, where you could have a different estimator, different types of standard errors. You could run this model as a multi-group SEM by adding a grouping variable and then selecting what invariance constraints you would like to implement. So it's very, very convenient, even for an SEM where you have to specify the model syntax yourself. Now, what else is there? When we click on this, we also find mediation analysis. Mediation analysis is an option where you have an indirect effect, so where you want to specify a model with an exogenous variable or more exogenous variables, an intermediate variable or mediator, and one or more outcome variables. And you can see here, this is again point and click. So it's super easy. You could have multiple predictors, you could have multiple mediators. I'm just making something up here. It doesn't really make sense, but just so you see how it works. So you can just click these over like you would in SPSS. You could even control for some background confounding variables. And so then this mediation model is estimated for you. When we go to options, we can get the standardized estimates. We can again display the LAVAAN syntax, R squared. We could also get the total indirect effects calculated by JASP. We can request plots and advanced options. So this is also very easy for mediation analysis and something that's very, very nice. You can see even with a bootstrap, you can do even a bias corrected percentile bootstrap for your effects. And so this is then a lot easier than it would be in a program where you have to use syntax. Here it's all point and click, and you get some nice output tables that for at least some of them you could use right away. In a publication, you just copy and paste them into a Word document, and then you have your output there, and there's not much work to do. Now, this takes a while because of the bootstrap with 1000 replications. You can see here that this is taking a little bit of time, but you see what you get the idea. So this is how JASP works, and you can see it has a lot of decent options for both factor analysis and SEM, as well as mediation analysis. Even growth curve models can be specified very easily in the software. So check it out if you like. This is really fun. It's also a great program for teaching. If you teach SEM to students, then the students don't have to mess around with syntax, and they can focus on the key things that they should be looking at rather than getting lost in some syntax errors or typos. So this is a program that I definitely love to use for teaching SEM in my classes. Thank you so much for joining me for this little tutorial on how to use JASP for factor analysis and SEM. And if you like this video, then please consider subscribing to this channel. Don't forget to check out the description for additional resources, and I'll see you next time.